Teleportation. You hear that word and what pops into your head? Star Trek, right? People just vanishing and reappearing somewhere else in a flash of light. Well, I'm going to let you in on a little secret.
Yep, you heard me. It's absolutely real. But to really get it, you've got to leave all the sci-fi stuff at the door. We're about to step into the truly strange, kind of wonderful, and let's be honest, completely bizarre world of quantum mechanics.
So here's the game plan. First, we're going to separate the Hollywood fantasy from the actual science. Then, we'll dive into the spooky physics that makes it all possible. We'll also talk about the one unbreakable rule that stops any kind of quantum copying. After that, we'll look at the incredible real-world experiments that have taken this from a lab bench all the way to outer space. And finally, we'll peek into the future and see how this could build a whole new kind of internet.
Okay, first things first. We have to reset our expectations. The real deal with teleportation is way more subtle, and honestly, a lot more profound than what you see in the movies.
This slide just nails the difference. On the left, you've got the sci-fi version we all know and love. Your physical atoms get zipped across space. But on the right, that's the quantum reality. And here, no atoms actually travel. No stuff moves at all. Instead, it's the information, the complete and total identity of a particle that gets transferred to another particle far, far away. The matter stays put. The identity is what makes the jump.
So here's the crucial part. Quantum teleportation is all about taking the exact blueprint of one particle, its quantum state, and perfectly recreating it somewhere else. But here's the real kicker. The original is destroyed in the process. This is not a copy and paste job. Not at all. A better way to think about it is like a kind of quantum reincarnation. The identity is reborn in a new body, but the original is gone for good.
So, how on earth is that even possible? Well, the secret sauce is one of the most mysterious and mind-bending ideas in all of physics. It's a little something called quantum entanglement.
Entanglement. It's this incredibly deep link between two particles. Once they're entangled, they basically act like one single entity. Whatever you do to one of them instantly, and I mean instantly, influences the other one. It doesn't matter if they're on opposite sides of the universe. They're not sending secret messages back and forth. It's deeper than that. They literally share the same identity.
You know, this whole idea was so bizarre that it even freaked out Albert Einstein himself. He couldn't wrap his head around it. He famously called it spooky action at a distance. And it's this spooky connection that is the absolute backbone of quantum teleportation.
Okay, let's walk through this using the classic Alice and Bob example. Don't worry, it's simpler than it sounds. First, Alice and Bob need a link, so they each get one particle from an entangled pair. We'll call them B and C. Now, Alice has another particle, A, and she wants to teleport its identity. So what does she do? She performs a special measurement on her two particles, A and B, at the same time. This measurement pulls out all the quantum information, but it also destroys particle A's original state. Then Alice just sends the result. It's just two ordinary bits of data to Bob through a normal channel, like an email or a text. Finally, Bob uses those two bits like a key. He performs a specific action on his particle, C, and poof! It transforms into a perfect, identical replica of what particle A used to be. The identity has been teleported.
Now, I know what you might be thinking. Wait a minute, why destroy the original? Why not just make a copy? Well, it turns out that nature has a very, very strict rule about that. It's called the no cloning theorem.
It's one of the most fundamental laws in the quantum playbook, and it's actually pretty simple. You cannot create a perfect, independent copy of an unknown quantum state. Full stop. The universe just forbids it.
And that one simple rule has some huge consequences. It means the teleportation process has to destroy the original. Nature demands a perfect trade-off. You can move an identity from here to there, but you can't have it in two places at once. No duplicates, no backups, only a perfect one-for-one transfer.
Now, this isn't just theory anymore. This isn't just chalkboards and thought experiments. For decades now, scientists have been proving this is real, taking teleportation out of the hypothetical and into the actual world. And just look at the progress. Back in 1997, it was a massive deal just to get it to work in a lab. Fast forward to 2012, and scientists were beaming quantum states over 143 kilometers of open air between islands. And then, just 5 years after that, China's Messiah satellite took it to a whole new level, teleporting quantum information from space all the way back down to Earth.
1,400 kilometers. Let that sink in for a second. That's the distance they achieved. This is not science fiction anymore. This is becoming a genuine feat of engineering.
So why does all this matter? I mean, besides being ridiculously cool, this technology is actually the foundation for a revolution in how we communicate.
Quantum teleportation is pretty much the key to building a quantum internet. And this would be a network that isn't just faster, it would be fundamentally unhackable. Think about it. Because the information is transferred without actually traveling through a physical wire or fiber, there's literally nothing for a spy to intercept. This could lead to a whole new era of ultra-secure data for banking, for governments, and for linking up the super powerful quantum computers of the future.
Of course, all of this leads to the one big question, the elephant in the room that everyone always asks. Forget about single particles. What about a person? Could we ever really, beam me up, Scotty?
Well, in theory, the physics doesn't say no. But in practice, the challenge is just astronomical. This number you're looking at, that's roughly how many atoms are in the single human body. To teleport a person, you'd have to perfectly scan the quantum state of every single one of those atoms, send that unimaginable amount of data, and then rebuild it perfectly on the other side. The scale of that problem is just beyond anything we can comprehend. So, yeah, we won't be teleporting people anytime soon.
And that leaves us with this final, really beautiful thought. What quantum teleportation shows us is a universe where information might be even more fundamental than matter itself. It shows us that an object's identity doesn't actually need to travel to get from one place to another. It can simply be rebuilt. And that, right there, is a universe that is far stranger and way more incredible than any science fiction story could ever be.